Welcome back to Energy 101. I feel like I say this every time. We haven't recorded in a while.
Yeah, we do say that
I
a lot.
actually just made a LinkedIn post begging for intros to people to come on our podcast because it's really hard just knowing who to talk to and really shape up content in a way that's helpful for newbies like us. So if y'all have any other suggestions after we get off, that would be amazing. Today we have Tara. Oh my God, I forgot to ask how you pronounce your last name.
Schneeberger.
Okay, I would have completely butchered that.
Schneeberger.
She is the director of execution at ProLytX, and she worked in petrochemicals for most of her career previously. And we have Will Welling, who is currently a technical consultant at ProLytX and previously a field engineer at a refinery. So
Cool.
This episode is going to be all about Downstream, which I'm really, really excited about because being from Midland, I know mostly only upstream exists in my world. So I'm really excited to learn about what happens after it's out of the ground.
It's a whole other world, my friends. So it's going to be a great conversation, and we're really going to see how it gets in the hands of the everyday consumer. So we'll see and talk through kind of the full life cycle.
I love it. Okay, do we want to start with introductions? You want to kind of tell about your background, what you've done previously?
Yep. So I'm a chemical engineer by background. So I got my bachelor's at UT at Austin, and then I went and got my master's at the University of Oklahoma. So trying to bridge school relations, unsuccessfully. No, but it was a fantastic experience. And so outside of school, I started working at a petrochemical company and really got to see the whole breadth of petrochemicals. I saw several facilities, worked in several roles, commissioned units. So it was really exciting. And then joined ProLytX about a year ago as the director of strategic execution. And so now our team is responsible for executing and supporting owners and operators for their digital transformation efforts.
Awesome. All right, Will.
I'm Will Welling. I am currently a technical consultant at ProLytX, but I started at the University of Houston where I got my mechanical engineering degree. And like Tara, I also went to grad school. I graduated from the University of Texas at Arlington in 2018. And my first job was at a big refinery in Texas City. And there I was a field engineer where I would go out and do walk downs and system turnover, worked with operations to make sure kind of commissioning but also I worked with databases and ways of managing projects on the owner's side. So kind of got an influence of how the downstream sector was struggling with their own digital transformations. Since then, I've done a few greenfield projects, worked for Hewitt for about a year, and then came over to ProLytX to help them with clients migrating data and working with that sort of thing. So
awesome. So y'all both went from really technical chemical things. I don't know how to say that, to digital transformation.
Right.
That's really cool.
What we found and what I'll brag on ProLytX is that, having an innate understanding of domain knowledge in order to roll out digital transformations is critical.
Yeah.
And so folks who have been in the trenches, out in the field, who've put their hands on equipment, hands down, have a fundamental understanding and more palatable understanding of what it takes to ratably execute digital transformations in the industry.
Yeah, and the problems they face.
That's right.
All of the things that come up. That's very true. I don't know that I didn't understand what ProLytX did or anything, but hearing it that way, and y'all have domain expertise of engineers helping out. That's really interesting. I didn't realize that.
Especially when we firsthand have seen the challenges, right? So we've seen, rolling out a connected worker with tablets as an example, which sounds great in theory, but when you have spotty Wi-Fi and you have to sync up tablets in a control room at the end of the shift, that's where the rubber meets the road. That's where the challenge is. And so that takes folks who have that innate domain knowledge to be able to help and partner with owners on making that dream a reality.
Right.
Yeah.
Right. Okay, I have so many questions, and I'm just going to like lay it all out, and then we can organize thoughts.
Yeah, that sounds good.
Okay, so first of all, very interesting on there's upstream where the oil is obviously brought from the ground. I'm really interested in not so much like midstream, obviously pipeline, but how does downstream receive, like what does that process look like from receiving the product to making it what it is? And then two, I really love like the day in the life of a field engineer. I don't know that I've ever talked to anyone who's worked at a refinery and what it's like and what you do. So I think that's very, very interesting. So those are my thoughts on.
Yeah, that's like my
Questions.
first question. What is downstream?
Yeah, let's start
I
there.
don't
Let's
know.
start there.
Yeah. So downstream is basically coming off of a pipeline and being received into a facility for manufacturing. So I'm familiar with petrochemicals. So I know we were talking earlier, but kind of the shale revolution in 2010 was truly revolutionary. It was revolutionary for upstream, especially compounded with fracking and horizontal drilling. But that was a tide that lifted all boats. And so when I know I said this story earlier, but when I was an undergrad at UT, I remember several professors saying, we will never build another petrochemical facility in the US. The costs don't make sense. The natural resources, it doesn't make sense. Everything will be built overseas. Fast forward to me graduating out of OU and then starting in the industry. And then within a year, I'm commissioning a brand new ethylene unit. And so essentially, the stuff that refineries and the upstream guys don't want, petrochemical facilities love it. And so it really reinforces that nothing is wasted, that even the gases and the natural gas liquids or NGLs that may not be desirable for upstream on specific applications, downstream manufacturing facilities love it. So specifically, it is ethane. We like ethane. So ethane is essentially comes off of a pipeline, and then there's several different units, but the ethane is transformed into a chemical called ethylene. And that is a beautiful molecule in the sense that it's perfectly reactive. And when you add additional chemicals or comonomers to ethylene, you get some really cool chemicals ranging from, polyethylene, high density, medium density, low density, all the way to specialty chemicals like synthetic motor fluid, the odorants that go in pipeline for detecting leaks. It smells like that sulfur. Goes into things like candles, sunscreens, lip gloss. So the applications from a petrochemical side are truly endless. And what's neat is that that's something that you can walk in a grocery store and you see it all around you. So the challenge is, can we as a society go a single day without using something that comes from oil? And right now, as it stands, the answer is no. It is absolutely integral to every stage of consumer goods. So it's been pretty impactful. So from a refinery perspective, what have you seen, Will?
Well, I'm not a process guy, so I'm not going to pretend like I know as much as Tara does about any of that. But it's largely the same idea, a little bit different. So, oil, when it comes in, has every hydrocarbon chain you can think of, from the really light ends all the way to just incredible number of carbon chains. And so what one engineer I worked with said, it's all just heat and pressure. Every unit, whether it's, the fluid catalytic cracking unit or, the alky unit or whatever, all you're doing is applying heat and pressure, and you're basically separating these compounds into certain cuts. So a refinery, what you get out of that is mostly fuels. We get, on the very light ends, you get like kerosene and jet fuel and things like that. You get gasoline, of course, and you get diesel. And then at the coker and things like that, you get like asphalts and Coke itself. like lots of really sticky, really heavy substances. So yeah, I mean, we would take in oil from tankers, from pipelines. And one thing that I thought was really interesting was that these facilities are almost like an organism in that they're connected to other facilities. So like Chocolate Bayou, which I think is a polyethylene whatever, they had pipelines in between them. In fact, one of our projects was we were commissioning them. I think they were supplying like excess hydrogen or something like that to go into one of our, whatever unit, like ultra cracker or something.
Right.
So yeah, I mean, just like, even though she was in the petrochemical side and I was refining, it's like, it's all connected.
Yeah.
Off gases of a refinery would be taken into a petrochemical facility and then processed. So there's a high level of integration, to your point.
Yeah. So, and to Tara's point, I mean, in today's day and age, it's just vital for everything, right? I mean, I think America consumes like 20 million barrels. Somehow over the last 50 years, we've always maintained about 17 to 20 million barrels a day of oil.
That's crazy.
That is crazy.
Yeah. So it's quite a lot. America's thirsty for oil, and and it takes a lot of work and a lot of jobs to make it all happen. So.
Yeah. So can you take us through like your day as a field engineer working at a refinery? Like, so when you think of roughnecks, they're getting dirty, there's oil all over them. What is a like field engineer at a refinery look like? Are you doing that like dirty work? I mean, I'm completely naive to what it's like in a refinery. So these might be really stupid questions.
Is it really dangerous?
Yeah.
Like working in a refinery
with gases and,
Well, yes. I mean, the short answer, yes. Start with the safety. That's always how you start off meetings anyway. Yeah, it is dangerous. It's incredibly dangerous work. I think with it used to be more dangerous. Now we have like integrated control systems, computers that kind of like help run these processes. Still incredibly dangerous. In fact, the refinery I worked at, the one in Texas City, just recently had a fire and there was a fatality and a couple injuries within literally the past 2 weeks.
Wow.
And then when I left, I remember I always, you check the news, there's always incidents going on. When I was at the Greenfield project construction, I would look and see, and there was an incident, where one of the oil tanks, like the manway busted or something. And there's always the potential. There's just so many points of failure in these
things
places
that could go wrong.
Absolutely, tons. So it is. I mean, they're good paying jobs, but there's
a reason they're good paying.
Yeah,
high risk, high reward.
Exactly. That's a great way of putting it. My job I wasn't as intimately involved with the process. I was brought on to kind of help with the small and medium and large capital projects. And they were, the margins at these facilities are all really tight. Like you're making like cents on the dollar of every barrel you buy. So they're always trying to extract just as much as they can. And so they were trying to manage projects on their own more than having outside construction companies like KBR or, Wood or whatever help with these things, Fluor in this case. So I was brought in to kind of help manage and help run the databases for like managing manpower, managing rental equipment, managing various other costs associated with these projects. And then on the other side, where I was actually a field engineer, to your question, finally getting to it, I would go out with the P&IDs and other drawings and basically do like a final checkout with operations and a few other folks, like the project engineer over that specific project. So we'd check, walk through the P&IDs, sometimes bring ISOs, things like that, bring quality inspections guys with us, do a final look around and basically sign it off and be like, kick the tires, all right, turn this thing on.
And when you turn it on, gas or whatever is flowing.
I was never around when they really turned it on, when operations would really commission it. So I didn't get my hands dirty quite like that.
But is that what
Tara
happens?
did.
Is that what happens? Like you basically turn it on and like pipe is just filled with.
That's right. So any time before a project, there's always extensive safety briefings that happen. So there's typically something called a management of change or MOC process where you do extensive hazard evaluations. You're looking at all potential sources of risk and trying to mitigate as much as you can. And I'm sure it's similar to very, very upstream, where in order to work on a piece of equipment or take a piece of equipment out of service and put something new in, you've got to isolate it safely. You can't have oil flowing through it. You can't have materials flowing through it. It needs to be isolated. So there's a practice called LTT, or lock, tag, try. It's also, I've heard, LOTO, lock out, tag out. And essentially that is, from an operations and maintenance standpoint, your line of defense, that you have locked out the section of equipment that you're going to be working on, whether it's a project or just maintenance. And then you lock it out and you test it. You make sure that energy is dissipated, that there's nothing in there. And then as you go through your management of change process, you're evaluating to make sure you've installed it correctly, you've had the right people work on it, inspect it, to Will's point. And then operations will bless it, say it's good, and then it will be ready to be put back in service. So at that point, you remove the locking mechanisms, you make sure everything's buttoned up, and then you slowly introduce whatever material was in that piping back into it. It could be gas, it could be liquid, it could be product, solid, but you introduce that back safely into the process. I personally, I always felt pretty safe in a petrochemical facility. While we do work with volatile chemicals, there are so many safeguards in place, making sure to protect folks, that, to me, driving to and from work in Houston traffic, I felt to be more risky than actually working in the manufacturing facility. So, I mean, we're geared up in the same way that upstream is. We've got our hard hat, we've got our steel toe boots, our fire retardant clothing. So we're suited up. It's hot in the summer, but recognizing it comes from a good place, that it's actually protecting us. So there's a lot, to Will's point, that goes in the day-to-day run and maintain. So from monitoring your manpower allocation to what work orders are out for the day, meaning what's the maintenance on the plate. If there's an unplanned unit shutdown, then it's all hands on deck, right? So operations, maintenance engineers are coming together to put together a plan and make sure that they safely bring that unit back up. So there's always something going on. I would not say it's like your classic mud and dirt. I didn't experience
slinging
that.
chains.
Yeah, it was actually very clean facilities. So a lot of the facilities that I worked at go through a pretty rigorous safety certification through OSHA. And part of that is cleanliness and your backlog on any findings or compliance items, and making sure that those are good. So there's quite a bit of rigor that goes into even installing a little valve, the amount of engineering paperwork and approvals, just to make sure that all considerations have been taken into place. So it's one of the most highly regulated and governed facets of our business, to make sure that we don't see incidents on the news, and that we send people home the same way that they came in, that they come in safely. So there's always that in our minds.
Yeah. Okay. So do y'all receive like a full barrel of oil and then it goes into different segments? Or is it like midstream does something with it and then y'all get it in a already different form? I don't even know if this, like, again, does this question make sense? Okay.
Good question. So we take a lot of natural gas liquids, and we take some streams from refineries, and basically they're just big towers, and they just separate materials. So there's a lot of chemistry behind it, recognizing boiling points of the various hydrocarbon components. And so the lighter components will volatilize to the top of a fractionation tower, and that goes into a separate piece of pipe. And you go through, and there's several takeoffs of a tower. The heavy stuff tends to stay on the bottom because it's heavier.
Right.
And so those different streams go to different end places. We will take some aspects of it, working in petrochemicals. Refineries will take some from the upstream guys, but everything has a purpose. So we are not ever receiving like, here's your barrel of oil, good luck. It is in a pipeline form, And it is a very tight spec most times of whether that's an ethane, a butane, a propane. We have specs on everything. And so that's a tight spec. We receive that certain feedstock. And then from there, that's when all the magic happens downstream with catalysts and the reactions to make the polyethylene and specialty chemicals.
Interesting.
That's awesome. When you were first talking and describing what you did, I had a picture of like a mad scientist, just like with tubes and everything, like just the reactions. I mean, you always have like these like typical thoughts when you think of like anything chemistry wise. So is it like that? Like, are you testing different things before you create the product, or I don't know how to I don't know how to finish that question.
Yeah,
Yeah,
like,
that's a
does it
great
look like a
question.
full on like chemistry lab and like
Like, is there a lab?
Absolutely.
Okay.
So most, if not all, manufacturing and petrochemical companies have a research and development section.
Okay.
They work very closely with manufacturing facilities. A lot of companies have pilot plants, which are basically just miniature versions of the larger operating units. And that's where you see more of your testing of new catalysts, new additives, new plastics and new chemicals before they scale it to the larger units. They really need to see what's the feedback from consumers, what's the feedback from customers, and then getting that feedback, they'll go into the lab, do a lot of tests on catalysis, on just reaction chemistry, and then from there they'll go to the pilot plant, see how it reacts, see how the equipment performs. Does anything foul? Does exchangers or filters foul up with this tweak of the formula? And if everything looks good, then they start to scale that into the larger operating units. And then there's, depending on the customer need, if they may like it, they may not. But there's all sorts of tests. I don't know if y'all remember, there was several years ago, there was really for like Doritos bags, and like they got really loud. Did y'all notice that? They were
Yeah,
like,
I remember that.
they were
I
like
absolutely remember
crazy
that.
crunchy. Like when you tried to open them, they were really loud. And it was because one of the larger like bag manufacturers was testing, and it's like, hey, this is, post-consumer recycled percentage. Let's test it out. And they thought, this has it's post-consumer. This is good. We're recycling, that's great.
Mhm.
But the feedback from consumers was, it is so loud. Do I need to put earplugs in to eat a bag of chips? And then it's like back to the drawing board, right? So
Yeah.
get the feedback, that continuous improvement feedback loop. And so went back to a different formulation based off of the feedback from the client. So there's a handful of examples where you're like, you see something roll out, and then it either becomes kind of a statement and long-standing, or you see it cycle back to the lab to try
That's
again.
wild. I don't feel like you think about like in the supply chain of Doritos or Cheetos, like
Yeah.
the actual bag it comes in. So is that who the customer is for like petrochemicals? They are supplying manufacturers of different products.
So your Procters and Gambles, your Clorox, they will take petrochemicals, and that's upstream because it takes, the package to hold it in. It takes, so I would say the breadth of consumer goods is all over the place. So nothing is left untouched from not only the material inside the packaging, but the packaging as well. Has some component of petrochemicals included in it. Yep.
That's crazy. It's probably even more than I thought. Like I already knew
Mhm.
like they're in everything, but to really think about every single thing you touch, from like you were saying, the layers of inside, what were you saying, of the
this Cheetos bag.
Yeah, that's wild.
Get a zoom in for that.
Yeah.
No, but I mean, this as an example, the Cheetos, and this is like any snack bag, tortilla chips, whatever. But there's multiple layers of petrochemicals in these, and this is plastic. And so it'll start out in this kind of granular form called these pellets. And these pellets are shipped off in rail cars or super sacks, depending on the client. And then they will melt it down. And then there's a lamination process for this. So there's multiple layers. So there's an outer layer, which typically has kind of like the logo. Then there's a sealant layer in there. There's a barrier layer that keeps out moisture, UV, because UV breaks down. So there can be several layers to something that's so simple as just a bag.
And it's crazy to think like bags of Cheetos, like millions of them, and they're like, I don't know, the whole process is just mind blowing to me over here.
Right. What's interesting too, from a sustainability perspective, is it's amazing the engineering that goes into the number of layers. It also makes recycling very challenging because there's so many different layers and so many different properties of the plastic. It requires typically chemical recycling is better utilized for some of these more complex plastics as compared to traditional mechanical recycling. So there, even on the back end from a sustainability perspective, there's all sorts of nuances that goes into how we sustainably manage these materials. So it's pretty fascinating. I can go through each of these if you want.
Yeah, let's do it.
I don't know if it's a natural segue, but
yes, let's do it.
So the next one on the docket, I've got these sugar packets here. So you may think, oh, I just rip it open, I put it in my coffee, and I never think about it again. But there's actually a coating on the inside. It's typically wax, which can be petrochemical based, and that's what keeps the sugar packet. It actually keeps it the granular sugar. If anybody's picked up a sugar packet that's been wet, it starts to clump. Nobody wants that, right? Yeah. So this is an example of something so small that has big impacts on the end consumer. Starbucks, not my sponsor, but if you want to sponsor, I will gladly sponsor. But that's a classic example of there is a plastic lining, in addition to the lid, but there's a plastic lining in the inside. So have y'all remember in the early days of like the paper straws where you're like enjoying a mojito and then the straw disintegrates in your mouth? They've come a long way. Yeah.
Paper.
You're getting your fiber in addition to your mojito. They've come a long way since then with, bamboo. I've seen all sorts of like much better materials that are sustainable, that's trying to mimic the properties of like a classic paper or a classic plastic straw. But for a Starbucks, it's there's a plastic lining in here, so it doesn't have that same effect of disintegrating and then having hot coffee or hot beverage everywhere. So that's typically made. You can either coat it or you can laminate it to the cardboard, similar to what they do for some of those chip bags. Now, I also have a candle here. I'm a big candle fan. My husband will admit that there's always a candle or two. But candles is actually it actually comes from petrochemicals. Now, there's the soy candles that there's different derivative sources, but a lot of it is petrochemicals. So you'll take ethylene, you'll run it over a catalyst, and it'll make a whole variety of chemicals. And one of them can be a heavy wax. Yeah. And so the wax will it's loaded in rail cars, big rail cars full of wax, and they're actually heated.
Are they like pellets?
No, it is.
It's melted wax.
It's like a big old rail car candle.
Wow.
Oh my gosh.
You just got to throw a wick in it. But it's a heated rail car, so it actually stays in liquid form.
Okay.
And then when it gets to the consumer or the client, they'll go and they'll add perfumes and scents to it. They'll add any colors. They want to get super artisanal. They'll add the dried flowers and all the fancy stuff into it that I like. So that's an example of that you would never even think of, even from like a candle,
Yeah.
that comes from the gas from from fracking, from shale.
Mhm.
So it's pretty crazy.
That is wild.
It really is.
Yeah. Now my last one,
Especially, hold on, especially since you say it comes from fracking. Like,
right.
for everyone who hates fracking, just look at your candle. You're
That's
using
right.
it.
There you
Look
go.
at your Bath and Body Works candle.
Yeah. So the last one I've got here, I've got a Tesla. And so this isn't meant to, tease, poke, or prod. It's the reality that even with electric vehicles, there's a significant component that comes from oil, whether that's the synthetic materials of the seats or in some of the plastic components interior, whether it's the high density polyethylene on some of the body of the vehicle, like the bumper. The gas tank is a big one, especially for internal combustion engines. You get better gas mileage when you have plastic fuel tanks, and those are done by rotational molding or rotomolding, and it's basically melting some of these plastic pellets, high density, melting it into kind of a molten form, and then putting it into a mold and letting it harden, and it reduces corrosion, it reduces any drag, and it's more economical from a miles per gallon than what you would see from a steel tank. So that's just a great example there. Tires is another example. That is big on the refinery side with some of the tar and the asphalt, but there's also petrochemicals that go into it as well, to help with the adhesion and some of the long-lasting tire characteristics to kind of the tread and things like that. And then there is also, this was news to me until just a couple years ago, but there's a synthetic motor fluid that is in the body of the car. And it's actually in the gearbox differential. It contains a synthetic oil to ensure that you've got a good transmission. So
Wow.
there's actually oil that runs in it. You don't have to get an oil change because it's an electric vehicle,
Right.
but it's a lubrication component to make
Right.
sure that everything is greased and running well. So
Hmm,
there's something that
interesting.
you would never even expect.
Yeah.
So, and then I've got, let's see, got a piece of paper which you would think, oh, you just stamp on these, the red and the blue lines, right? But there's actually chemicals needed to help with the color of the paper, to help with the adhesion of the inks and the dyes, the bleaching process. So even something fundamental as, I know school's out for the summer, but it'll be back in session before you know it, and buying something as simple as that has ramifications.
I didn't know that.
Yeah. And then a milk jug. This is classic example of polyethylene, and this is manufactured through blow molding. So blow molding is basically, it's that molten plastic, and you blow it into a mold, and you do a little last burst of air, kind of fit the mold, and then you run cold water or cold air over it, and it solidifies immediately. So think about not only from a consumer perspective, just the weight of it, but even transporting these to your HEBs, your Walmarts, your Krogers, your grocery stores, what the impacts that has for trucks and their miles per gallon and their fuel efficiency, right? What's really neat about all these different types of plastic is that as the chemical process completes, you can add different additives to it, and it gives it different property. So, this is kind of opaque. It's not totally transparent, right? So there's an additive added at the end part of the process to give it the characteristics. The same thing can be said for shiny plastic, like coat hangers, for example. Those are given an additive to give it that shiny, high gloss look. And so the same thing can be applied for, there will be additives for UV blockers to help prevent degradation from the sunlight for some outdoor equipment and sports like kayaks or basketball. So there's all sorts of applications, and everything is engineered to it's the science of engineering. Everything has a purpose, whether it's the lining in your Starbucks, whether it's the color of a milk jug. Everything is done and thought of and optimized. And I can say that for refinery and for petrochemicals, everything is done for a reason, in order to make sure that we're, from a safety and compliance perspective and from a consumer goods perspective, everything is just meticulously thought of to make sure that kind of hitting on all cylinders. So,
Yeah. I want to quickly go back to when you were talking about the shale revolution and it really making an impact for downstream as well. And you said you were on a refinery facility, something.
So I was on a petrochemical facility, and I was still a newer engineer, just a couple years out of school, and there was an opportunity. They were commissioning a brand new ethylene unit. Now, an ethylene unit, it's a glorified oven. There's a lot of engineering that goes into it, but for all intents and purposes, you're taking that ethane that's a gas or a byproduct that upstream guys don't want, the refiners don't want. They take it and they heat it up to very hot temperatures, and they break it down and to its most core monomer. And then they basically go through with a series of compressors and then those larger fractionation towers, and they make ethylene. And ethylene is really, that's the molecule that makes it happen. So ethylene can be reacted with the catalysts that go and make all of this. But talk about an opportunity to be on a project where you're commissioning, and they're massive. I mean, you can see them from the road. They're massive. And I knew that unit like the back of my hand because I went through all those stairs. And you've got your punch list, you're an engineer, and you've got your clipboard, and you've got your engineering documents, and I'm tracing lines to make sure that it matches, the isometric drawings. I'm making sure that, maintenance is working. The project crews are working on what was prioritized for the day. And so going into the structure to inspect it, to make sure everything was installed correctly, going into vessels, I'm like a 2-3 year engineer, and I've got my hard hat on, and, and that's how you, I was doe-eyed, bushy-tailed, but, but it's so exciting, because that's how you cut your teeth, and you have such an appreciation and a respect for all the engineering, both upstream to get it to that point, all the design engineering from EPCs, and those guys who were designing the equipment to actually getting it installed, and then being one of the few folks who, working with operations inside the control room, and everything's ready to go, everything checked out, green lights ready, and being able to say, let's start introducing feed, and seeing everything kind of light up, like you're introducing feed for the first time in a brand new unit. That's cool. It's a cool milestone, and something that we never thought would be possible in the US if it wasn't for shale. So, there's plenty of great partnerships, that happen in the Middle East and in Asia, but there is something about having new manufacturing facilities being built from the ground up in the US, whether it's in the Golden Triangle, whether it's off the Gulf Coast, and even the NGL units that have popped up around Mont Belvieu. It's been fantastic to see just all the downstream components that come from shale, that come from the horizontal drilling. So it's been really cool.
Yeah, that was going to be my question: is what caused it to how did the shale revolution lead to like us having a facility in the US, and it was because of the production?
That's correct. Right. So because we were able to access more oil in creative ways, right, with horizontal drilling, oil is, if it's a great well, it'll be majority oil. But 9 out of 10 times, there's always going to be some gas with it. It's not 100% oil. So the question was, well, what do we do with the gas that we're extracting with the oil? And one option is just you flare it, which to me is wasteful. if there's an opportunity to utilize it, let's do it. And so that's when we really started seeing a lot of ethylene units and then polyethylene units and natural gas liquids or NGL fractionators be built, is to really process those lighter ends and make it usable for downstream facilities to be able to go into all of this.
Do you know why a company would choose to flare over sending it downstream? Like, is there any type of gas that has to be flared?
I don't know. Short answer, I don't know. I think in general, the flare is a safety system.
Okay.
So the flare, it should be used for safety. And so if there's a unit upset or if there's any continuous burning of typically a flare will go with nitrogen and methane in a flare, but it's used as safety. So in general, if they're flaring, it's typically intermittent because there's not the facility there to process the gases. They don't have that available, or it's just it was the need at the time. But yeah, in general, you try to minimize flaring as much as you can.
Yeah. Yeah. Do you have any questions?
I think that's it for me. Before we go into
Do y'all have
rapid
anything
fire.
else you want to kind of talk about or anything that you didn't really get to explain?
I think I'm good on my end. I think a lot, I do get a lot of feedback on where's all this stuff going.
Yeah.
Like we're building new facilities, and we're creating more of these consumer goods. Where are they going? And what we're seeing is there's a rise of middle class globally, whether that's in Asia. It's predominantly in Asia, but there's also localized of folks coming into the middle class and seeing what consumer goods are available and wanting to have that opportunity. So I heard a great analogy is, somebody coming into the middle class who would use these materials is going from using a bar of soap to a bottle of shampoo.
Right.
And that's where you really see that incremental demand on some of these consumer goods, whether it's from petrochemicals or from renewables. I think consumer goods and these end products are really paramount, and they're a staple to society.
Yeah. Yeah. And you said this multiple times. It's just cheaper to use petrochemicals than it is to use other type of things. It's cost efficient.
Right.
And that's a big thing for us is educating people on, hey, we want the world to be able to access cheap and reliable energy.
Right.
And you can't do that right now without oil
Right.
and gas.
I actually have some really good stats for you based off of that convo.
Oh.
An example of that is like for food wrappings, that 50% of food is wasted annually. And a third of that is because of appearance. And you're like, well, what does that have to do with petrochemicals? What does that have to do with oil? And the reality is that there's a preservation factor with plastics that, as an example, a cucumber, it's typically lasts freshness 5 days unwrapped, but 14 days in plastic. Red meat, vacuum packed, that's sealed packaging, preventing oxidation, that has a shelf life of 6 days compared to 3 days. So it basically doubles it.
I've never thought about that. Like I've never even realized.
And bread is the most infamous on, preservation of freshness. You can triple or quadruple the shelf life of bread by using plastic packaging. And so what that means is it's less waste.
Right.
And it's able to, for a supply chain and transportation, we can transport food to broader locations, geographic locations. So it's not just the Starbucks cup or the candle. It comes down to food preservation and not wasting as much, especially like going to landfills. 50% of food wasted goes into landfills. So because of a third of it is because of appearance, which is crazy to me.
Yeah, that is crazy.
That's wild. I really have never thought about that. That's very interesting. It's hard to understand how people can demonize it whenever you like really sit and think.
Right.
Yeah.
Absolutely. There's definitely a place and a time I'm all for innovation. So if there's innovative ways to produce plastic sustainably.
Yeah, because I'm like, what is
100%.
what's
With-
the alternative?
Right. So, I'm excited to see all the renewables come up from a plastic perspective. But the price point is challenging.
Mhm.
That's it. Right now,
Right.
it's not cost efficient for anyone except, probably top
Right.
Yeah, the upper class.
upper class. Yeah,
Right.
there we go.
So as soon as we see it, as we see some scalability and advances within technology, I'm all for more innovative ways to continue to see development in consumer goods. But in the interim, we're going to continue to do what's helps our clients at the end of the day with their consumer goods and making sure that folks are satisfied.
Yep. Yep. And I think the majority of the oil and gas industry would agree with you that renewables isn't a bad thing. We're all really excited. And I think that there's a time and place for it. And you can't do it right now without oil and gas. Just
Right.
There's
Yeah,
also an
impossible.
incredible amount of plastic that goes into those, like wind turbines and offshore wind turbines and,
Right.
and
Solar panels.
solar panels.
Yeah.
Yep.
Yeah. I'm all for blended. It should
Mhm.
not be one at the
Yes.
sake of another. It should be blended based off of a case by case scenario and let the consumers vote, right? Let's see
Right.
what makes sense and what place we have for those specifics. But you've got a cool little sign out there that says evolve or die.
Yeah.
That's a perfect example of continuing to innovate
Yep.
and find the best solution.
Yep.
Right.
Yep. That's really what Digital Wildcatters is all about, and helping foster the community to do that.
Right.
Yeah. And we like to say energy addition instead of energy transition because it's an addition
Mhm.
where consumers are just consuming more and more
Right.
energy as technology grows, the use grows. So
Exactly.
yeah. Do you want to do your questions?
Yeah, we're gonna do rapid fire really quickly.
Oh, wow. Cool.
All right, number one.
I wasn't expecting that.
What's the number one misconception about the energy industry?
That's a good one.
I've talked too much, Will. It's on you. You get this rapid fire.
Misconception. Well, kind of segueing off what we were just talking about, I think a lot of people don't appreciate just the number of jobs and scale of the industry. I think people who don't live in the Gulf Coast area realize just how valuable it is to the people down here,
Right.
whether it's upstream or downstream. I don't think people realize that welders can go out and make six figures, that pipe fitters and those guys working turnarounds can make, a year's salary in one quarter. I don't think people appreciate how hard they work. And just, the kind of toll that they take on their bodies and that kind of thing. I think people also don't appreciate the fact that plastic and petrochemicals is in everything, literally everything.
Our clothes,
Yes.
So, everything.
Or makeup?
Yep.
makeup, everything.
I love that you said that. And being from Midland, I always talk about the opportunity there to make six figures right out of high school. Like, that's insane. And it's amazing. It's one of the reasons that I love Midland so much is because if you work hard, you'll get rewarded.
Right.
And I think that's really cool. And I don't think people realize how hard it is. And not only how hard it is on the person working, but their family, they pay that price. They don't get to see them. They're
Right.
always called out on
Mhm.
birthdays, holidays. It doesn't matter.
Yep.
And it's actually what led, I think, my dad was an engineer. He worked for Halliburton for 40 years. His work ethic, I mean, insane. And then I watched my husband. He was actually a roughneck, worked his way up on the rig, and it in turn made me be very independent at home. I have 3 kids. I had 3 kids when very little when he was out there,
Mhm.
and I had to do everything on my own. And it's not something that I was like, "Hey, you're home from work, help me do this." Like, no, he's tired, and it does take a toll on their body. So I'm glad you said that. I don't think anyone's ever said that, and that's
Mm-mm.
one of my favorite tangents to go on.
Yeah.
Number 2 is why we should care. So like me, someone that came from outside of the industry, didn't know anything about it. Why is it important to educate people that don't know anything about it?
Are we switching back and forth, or is this?
Or you can both answer.
We
Yeah.
can both answer. So why is it so important?
Yeah, like why it's important to educate people on why they should care, essentially.
I think knowledge is power. I think
Right.
it's very easy to see volatile things in the news, and I think it's another thing to actually fundamentally understand
Mhm.
what's the intent. The intent is good. We care about the environment, right? We care about each other. It's a very close community. I would say I keep in touch with folks that I've worked with over the years, and it's fantastic that to build those connections, networks. You really are a team, especially on shift work.
Mhm.
A lot of the folks that I worked with been on the same shift for decades. Longer than they've been married, longer than they've had families. They've known the folks that they've worked with on that shift, and that builds a camaraderie, and that builds strong rapport. So there's a lot of strong teamwork and building there. Yeah. Anything else, Will?
So the question was, why is it important to educate people on the
Yeah.
the importance? Yeah, I just think that, I mean, in modern life, people just take everything for granted.
Mhm.
I don't think it's just people aren't aware of how much it takes. Like I'm still shocked when I look and see, even gas is $4 a gallon. I'm like, just the amount of work and like the distance that hydrocarbon traveled out of the rock, like all the way across Texas or out of the Gulf of Mexico or wherever, and then the processes it went through and like all the design and all the like everything it went through, and it's still only $3 a gallon. Like that's a miracle.
Yeah.
That is a miracle.
That is insane. How many jobs it employs. Yeah.
Yeah.
So again, it's just appreciation. I think people just need to realize, like, yes, there are consequences to burning oil and gas, but like what it gives you and what it takes to get there.
Right.
So
Yeah, I like that answer. This is our favorite one, and
Uh-oh.
you guys both have to answer. What's your most embarrassing story in your career?
That's easy.
Well, then
Easy.
you go first then.
Okay, well, I won't tell.
No,
He's
you
like,
have to-
most
now you have to
embarrassing.
censor.
Yeah, I mean, I can't dog myself too bad. I've shown up to the control room on more. So you go out, you go to the control room, tell operations what you're about to do, and then they sign off on it, and you go do your thing. I've shown up to the control room without like my steel-toed boots. I was wearing my tennis shoes without my hard hat, without my glasses. I'm just like, and these are different occasions, but like I'm can be forgetful. So they're just like, "What are you doing? Where's your hard hat?"
Right.
That kind of
Safety
thing.
basics.
So you
101.
got
Oh,
kicked
yeah.
out.
Yeah,
You're
they're
like,
just like,
hey, leave.
go back and get your
Yeah.
steel-toed boots or whatever.
Yeah.
So
That's funny. Mine is when I was commissioning a new unit. I had a great relationship with the operators and maintenance folks who were helping support that. And you're wearing your hard hat, and sometimes we kind of play pranks on each other and stick like a Post-it note on the back or whatever. Well, I was walking around like all day. One of the operators put a pink ribbon, like a streamer, on the back of my hard hat.
You had no idea.
And I had no idea. And so I'm walking around all day, and folks are kind of turning and look at me, and the wind was gone, and my pink streamer is kind of flowing, and they're kind of turning and looking, and I'm like, man, am I out of compliance or something, And so at the end of the day, I take off my hard hat, and I see this pink streamer. And so the joke was, hey, you got tagged, you got your, the pink streamer. And what's funny is I still have my hard hat. I still have that hard hat, and I kept that pink streamer on there. And so every time somebody asks, like, what's up with the pink streamer? And I'm like, it's a long story, but just go with, it's now a windsock. It now tells me the direction of the wind. So it's for safety purposes now, but it's, and that just goes to show that it's a community of folks.
Yeah.
It's a family. Folks look out for each other. They know their kids, their family's kids, and so it really is a tight network of folks building those memories together.
I love that.
I love that too. That's awesome. I love that you still have it.
Yeah.
Okay, this episode was really, really fun. It made me honestly want to go to school for chemical engineering. At the very least, I want to go on a field trip.
Yeah, so
Sure.
really quick, I lived in Deer Park and like where all the plants are and
Yep.
stuff, and we would go on field trips to the plants.
Oh,
Like we went to Lubrizol
Mm-hmm.
on a field trip there.
Yeah.
Was it
Yeah,
cool?
in elementary school. Yeah, it was, from what I can remember, it was super cool. But like
Yeah.
that's just crazy. You live over there and like your field trips you're going to the plants.
Right.
Yeah, it
You
was super
actually
cool.
see it in person. That's
Yeah.
awesome.
yeah, that is really cool. We never did that on like a drilling rig in
Yeah,
Midland.
could you imagine a bunch of like 6-year-olds on a
Yeah.
drilling rig? Someone would
we
be getting
did.
fired.
We did get to go to the museum and do like a lock-in
Oh, that's cool.
thing overnight. Yeah. Anyway, so where can people find y'all if they want to learn more? Y'all talked a lot about ProLytX in the beginning. Where can people find you?
So we're on social media. We're on LinkedIn, and we also go to ProLytX.com, and folks can reach out to us there. But we're happy to help support digital transformation and help owners and operators with their roadmaps.
Awesome. Anything else?
I think that's
That's it. All right.
it.
Thanks everyone.
We'll catch you next time.
Bye.